So here is another question on diode connected circuits, and this is a very interesting one. We'll go into the detailed analysis of this circuit. It looks like a very simple circuit, very straightforward, where we have two silicon diodes, and they are connected to one of the diodes. D1 is P end is connected to 10 volt, the other is connected to 0 volt. Both of them are connected to one point. Then there is a 1 kilo ohm resistor, and we have to calculate this output voltage. So the solution of this circuit is very simple, but why I have picked this circuit, it will be a very interesting thing, so we'll discuss that later. So first let us determine the parameter which is asked here, this output voltage. So as you can see, the first diode D1, its P end is connected to 10 volt, the N end is connected to ground, and the second diode D2, its P end and N end both are connected to 0 volt. Ground means 0 volt. So obviously D2 will be off or open circuited, and D1 will be on. It will be replaced by its equivalent circuit, that is the built-in potential. Here there is nothing mentioned about whether the diode is ideal or not, so we have to assume that we have to consider the built-in potential. Nothing has been mentioned about the forward resistance, so we'll not take anything, we'll simply consider its built-in potential. So the equivalent circuit will be something like this. Okay, so now we'll find the current flowing here like this, the current which will be flowing. So if we apply KVL, it will be 10 minus 0.7 minus I into 1 kilo ohm equals to 0. That implies I is equal to 9.3 milliampere, and V0 will be 9.3 milliampere into 1 kilo ohm, which is equal to 9.3 volt. Okay, the solution of this circuit is very straightforward, but actually it has a very interesting application which is related to digital electronics. This circuit here is actually a 2-input OR gate. Okay, a 2-input OR gate. How? Let us see. Now we will discuss all these things in digital electronics, where we'll discuss the implementation of logic gates. There are various ways to do it. One of the methods is this one, using diode and resistors. We can implement it using BJTs. We can implement it using field effect transistors. We'll discuss that in detail, but here just let us discuss it in a quick way. It will be very interesting. So what is done is that logic high or logic 1 here is this supply voltage here, which is equal to 10 volt, and logic 0 low is ground, 0 volt. Okay, this is high, this is low. The truth table for OR gate, we all know, we have discussed. Two inputs, let's say we call it x1, x2, and let's say this is y, the output. So it is 0, 0, 0 1 1 0 1 1. So in this case we know why the OR is x1 or x2. So only in this case it will be 0, in all the other cases it will be 1. Now that we have discussed in digital electronics, and this is the general principle of OR gate. Okay. Now how this circuit can be used to implement it. So in order to simplify our discussion, let us assume the diode is ideal. Let us cut the built-in potential 0.7 volt thing, okay? Because if we include that, it will be unnecessarily, the discussion will become complicated. Let us assume that the diode is ideal. So when I say the diode is ideal, both the diodes are ideal, it means that when the diode is on, it means it is short circuited. When it is off, it means it is open circuited. So this 0.7 volt small amount of built-in potential, it will lead to unnecessarily you have to calculate, so it will unnecessarily complicate the discussion. So we are taking this, we are assuming that the diode is ideal. Okay. So here this case, the one which is given here, we have this is high or logic 1 and this is low, logic 0, 1 0. So the result should be 1, logic high, which means that the output should be equal to 10 volt, then the discussion will be valid. So in this case here, this diode here D1, it is forward biased. It means that this will be short circuited, this thing will be short circuited. So here I am just drawing it again. This is short circuited, this diode, and this is open circuited, the second diode. This is 10 volt, this is 0 volt. So you see this V0, it is directly connected to this 10 volt. This 10 volt, it is directly connected to V0. This point is directly connected to 10 volt. It means that V0 is equal to 10 volt. Here the 9.3 volt came into play because we considered the built-in potential. If we would have a high ideal diode in place, then V0 would have got exactly equal to 10 volt, which means that the output is high. So here this condition is for this 1 0, this one 1 0, output is 1. So let us see the other cases. Okay, let us see the other cases. So for that, let us erase all these things. Okay, this one. Okay, so here let us say the other condition. This one is low, this one is high. Okay, so it means that this will be 0 volt and this will be 10 volt. This is 0 volt, this will be 10 volt. This is 1, this is 0. So in this case, this one will be open circuited, this diode D1 will be open circuited, this one will be short circuited. Okay, so here this one is short circuited, this one is open circuited. Okay, again the same thing here. This is 10 volt, this is 0 volt. So again the same thing, V0 is connected to 10 volt, output is equal to 10 volt. We have got the result, again high, that is 0 1, this one, we got the result, this one. Now let us check the other cases, that is when it is 0 0 and 1 1, how the result will be. First let us see 1 1. Okay. Okay. Okay, this is 10 volt, this is also 10 volt, logic 1, logic 1. In this case both the diodes are on, they are short circuited, this is also on, this is also on. So anyway it is getting connected to 10 volt and the output will be high either way. When both the diodes are 0, logic 0, that is 0 volt and 0 volt, when both the diodes are 0, that is 0 volt and 0 volt, both of them will be open circuited, both of them will be open circuited. So in this case there is no direct path which connects it to the higher potential, and the only way it is connected, a direct path is connected, is to the ground, here to the ground. V0 in this case is 0 volt, which is low, which is logic low. Okay, which is this one. So we discussed the 0 1, 1 0, 1 1 and the 0 0. So this is how the diode and resistor combinations can be used to implement logic gates. Okay, and here I willingly I chose the this concept, ideal diode, so that we can directly understand how things happen. But normally the diodes which are used, they consist of some amount of built-in potential, some amount of forward resistance. So we get the result in terms of 9.3 volt, which is very close to 10 volt. So 9.3 volt is considered as high and 0 volt is considered as low, or something like that. Okay, so when built-in potential is considered, this much 0.7 volt is it is neglected, and we consider this as high, 9.3 volt. But in order to avoid confusion, I took this ideal diode case so that we can understand it in a better way. So here was an interesting question related to diode connected circuits. The question was very simple. The result that we wanted, that was very simple, straightforward. But the implementation of this circuit to design logic gates, that was an interesting concept which we discussed. Okay.